everybody. Today we're going to be doing section 11.3 called Area of Regular Polygons. So a regular polygon is a polygon or a shape that has all equal sides and all equal angles. And here you can see we have a regular pentagon. It's inscribed in a circle. And one of the new vocab words for today is the word apothem. And an apothem is kind of like a radius. In a circle, you can have a radius that starts at the center of the circle and goes to the edge. Well, in a polygon, you have what's called an apothem. And so right here, FP is an apothem. It starts at the center of the polygon and goes to the middle of one of the sides of the polygon. Let's actually write the definition out. So an apothem is a segment drawn perpendicular to the side of a regular polygon from its center. And an example of an apothem in this case is segment PF or FP. So it starts at the center of the polygon and then goes perpendicular to one of the sides of the polygon. Central angle, the other word here, you're already kind of familiar with that. But in a polygon, there's a limited number of central angles. So for instance, in a pentagon, you're only going to have 5 central angles. And an example would be right here. This would be a central angle. It would be an angle whose vertex is at the center of the polygon, and then its sides go through consecutive vertices. So let's write out the definition here of a central angle of a polygon. It's an angle with its vertex at the center of a polygon, an angle with its vertex at the center of a polygon whose sides go through consecutive vertices. And an example of a central angle that you can see in this picture right here is angle APB. Angle APB, that green angle, is a central angle. Let's take a minute and identify some parts that you see here in this picture. So the center of both the polygon and the circle in this case is K. A radius, now a radius is part of a circle. It starts at the center and goes to the edge. So for instance, KG would be a radius. Also KH is another radius. Make sure you put the segment bars above them. But an apothem does not go to the edge of the circle. It goes to the edge of the polygon. So in this case, segment KL is an apothem. And the only central angle that's drawn in here is angle GKH. Angle GKH would be a central angle. It goes through consecutive vertices of the polygon, which in this case is a square. It does say find the measure of each central angle. Well, think about all the central angles that we can draw in. Here's one, here's one, here's one, here's one. If we added up all of those angles, they would add up to 360 degrees. In this case, our polygon has 4 sides or 4 central angles. So if we take 360 and divide by 4, we get 90. So the measure of each central angle would be 90 degrees. So these angles in here would actually be 90 degrees. And you can see, oh yeah, they do look like 90 degrees. All right, so on this one, go ahead and pause the video and see if you can answer these 5 questions. When you're done, go ahead and unpause. So check your first 3 answers. And then for the next one, for the central angle, I would say a good central angle would be angle KRL. Could also call it angle LRK. And to find the measure of those angles, like this angle right here, first you have to know how many sides you have. Now you can see here we have a hexagon. A hexagon is 6 sides. And so if we take 360 degrees divided into 6 parts, we get 60. So each central angle would be 60 degrees. So if I draw that in, here we have 60, 60, 60, 60, 60, 60. They would all together add up to 360. Before we go any further, will you please pause your video and without using Google, without using Siri, will you fill in the names of as many of these polygons as you can think of? So take about a minute, go ahead and pause and fill in as many as you can. Ready, go. All right, so filling these in, we have 3 sides is a triangle. 4 sides is a quadrilateral. A lot of people forget and write square or rectangle or something like that, but quadrilateral is the big name for the whole group of 4-sided polygons. A 5-sided polygon is a pentagon. Maybe some of you have visited the Pentagon in Washington, D.C. It actually has 5 sides. And inside of it, there's a courtyard that is also the shape of a pentagon. Pretty cool. 6 sides is called a hexagon. The way that I remember this is 6, if I write out the word, 6 has an X and hexagon has an X. 7 sides, you might have forgotten this one. It's heptagon. For some reason, that's a hard one to remember. 8, most people remember it's an octagon. Like an octopus has 8 legs, an octagon has 8 sides. 9 is nonagon. Sort of looks like 9, but it's non. 10 is decagon, like a decade. Decagon means, or decade means 10. You might also think of, maybe you've learned Spanish or another language. Diez starts with a D. Oftentimes a word associated with 10 starts with a D, so decagon. 11 does have a name. I believe it's called a hendecagon, but for our purposes in math class, usually once you get to 11, you can just call it an 11gon. The only other one that I really worry about the name is 12. And 12 is a dodecagon. 2 ways that I remember that. One is dough, kind of starts out like the word dozen, and 12 eggs are in a dozen, right? And then the other thing, again, if you go back to the languages like Spanish or Italian or things like that, dos is 2 and dec is 10. So 2 plus 10 is 12. So decagon, dodecagon is 12. So think back to middle school, maybe even elementary school. You might have been given a problem like this before where it says find the area of the regular hexagon with side lengths of 5 centimeters. Well, hexagon has 6 sides and it's regular, which means all the sides are the same length. So if one side is 5 centimeters, all the sides are 5 centimeters, all the way around, and so on. It says they want you to find the area of this regular hexagon. Well, when you were in elementary school, what you learned how to do was you took part of the hexagon, you took this triangle, and you figured out, oh, it would take 6 triangles. So this one, this one, this one, this one, this one, and this one. It would take 6 triangles to fill up that hexagon. If you can just find the area of one triangle, then you should be able to multiply by 6 to get the area of the hexagon. So let's actually try that. Area of a triangle, remember, is base times height divided by 2. So in this case, the base is 5. The height, I believe that's an 8. Yeah. The height is 8 and then divide by 2. Well, 5 times 8 is 40, and 40 divided by 2 is 20. So the area of one triangle here is 20 centimeters squared. How do we get the area of the hexagon? Well, we're just going to take that 20, and it's going to take 6 triangles to fill it up. 6 times 20 is 120, and remember it's an area, so it's centimeters squared. So 120 centimeters squared would be the area of the whole hexagon. So, of course, we can't just keep it that easy. You're in high school geometry now, so we're going to crank it up a little bit. So number 4, it says find the area of this regular pentagon. We're going to use the same type of method where we divide it into triangles. So in this case, you might notice this triangle right here. Notice this is a central angle. Well, this pentagon can be made out of 5. So we have 1, 2, 3, 4, 5 triangles. So kind of using the same method, we're going to find the area of a triangle and then multiply by 5 to get our entire area for the pentagon. Okay, so look at the triangle though. The triangle, this is the base and this is the height of this triangle outlined in red. Do we know either of them, the base or the height? The answer is no. So that's what makes this problem a lot more difficult than the last problem. So I'm going to show you how to do these problems. It's going to be a lot of work. They're going to take 6 steps each. I like to call these the 6-step problems. But here we go. So step number 1 is we are going to find out how big is a central angle. So step number 1 is find a central angle. And I'm going to write out the steps this first time through so that you have them written down. So in this case, it's a pentagon. So take your 360 degrees and divide by 5 to figure out how big this angle is right here. I believe that is 72 degrees. Step number 2 is you're going to cut the central angle in half. So take half of the central angle. So in this case, we're going to take 72 and divide it in half, which is 36 degrees. Now, what we just did was we cut that 72 in half, and so we can see this side is 36 degrees, and this side is also 36 degrees. But altogether, that central angle was 72. All right, step number 3 is you're going to find the base of the triangle. Now, our base of the triangle is going to be the distance from R to Q. Okay, so we have to try to find that base of that triangle, the bigger triangle, triangle PRQ. Well, what I was thinking is maybe we could find just half of it to start with. What if we could find the distance from R to S? I'm seeing a little right triangle in here. So I see, I'll just redraw that triangle up here. I see this is 36, this is 90, this is 10, and this is the side we want to find. So if you imagine I just drew that triangle up there. Well, we can use SOHCAHTOA. And so oftentimes you're going to have to go back to your trigonometry and decide which of these 3 ratios would you use. And so here's your angle. The x is opposite of that angle. That's the side I want to try to find. The 10 is the hypotenuse because it's across from the 90. So if you think about opposite and hypotenuse, O and H, we're going to choose SO. S stands for sine, so we're going to go sine 36 equals x over 10. Multiply both sides by 10. Those will cancel out. And then you need to take your calculator and you're going to type in 10 sine 36, and I believe you should get 5.88. So what we just figured out was this little distance right here from R to S is 5.88. But remember, the entire base goes from Q to R. And so to get the entire base of the triangle, you're going to take 5.88 and double it. So I believe that is 11.76. So 11.76 is the base of your triangle. Step number 4. Now you're going to find the height of the triangle. Now the height of the triangle, let's see if I can get a color on it. It's going to be right here. It's blue. So again, we're dealing with this big red triangle right here. The base we now know is 11.76, and now we need to find the height. So I'm going to use SOHCAHTOA again. I'll call this blue side Y. And so if I was going to try to find that side, my triangle would look like this. This would be my Y, this would be 10, this angle is 36, and this is 90. So I think I'm going to have adjacent and hypotenuse this time, if we look at this angle 36. And so that's part of CA. So we're going to go cosine of 36 equals adjacent over hypotenuse. Multiply both sides by 10. That cancels out. And then I'm going to type 10 cosine 36 into my calculator. And it turns out that we get 8.09. So the height of the triangle is 8.09. Step number 5. Hey, this is cool. We have the base of our triangle. Here it is. We have the height of our triangle. Here it is. So our fifth step, step 5, is we can find the area of the triangle. So find the area of the triangle, which remember, area is going to be base times height divided by 2. So we're going to go, area for the triangle is 11.76 times 8.09 divided by 2. We're going to type that in our calculator, and we're going to get 47.57. And technically that's inches squared. Finally, since we know the area of one of our triangles, the last step is multiply by the number of triangles. So in this case, we have a pentagon. So we're going to multiply by 5. So we're going to take our 47.57 and we're going to multiply by 5 because we're going to need 5 triangles to fill that up. Our total area comes out to be 237.85 inches squared. Now, one of the things that might have happened to you is your answer might be slightly different. Like it might be 236 point something or 238 point something. It's fine, and the reason is it just really depends on where you round. I try not to round at all until the very end. Like I just try to keep leaving my answer in my calculator and then building off of it each time I do something to the problem. Hey, that was fun, huh? Check that out. Okay, let's try the next one. Number 5. Find the area of a regular octagon. An octagon has 8 sides. So we're going to go through the 6-step process here. Step number 1 is you find a central angle. So you're going to take 360 and divide by the number of sides, which is 360 divided by 8 for an octagon. You get 45 degrees. Now what you just figured out is this angle right here is 45 degrees. But our second step is to take that 45 degrees and cut it in half. Why do we do that? I'll show you. So we cut it in half, we get 22.5. Cut it in half right here. And the reason we do that is because then what happens is we get a little right triangle where this side over here is 8, and we can use the fact that this is a 22.5 degree angle to find that part down on the bottom. And then once I know that part, then that can be doubled to get the entire base of our triangle. Okay, so step number 3 is you're going to try to find the base of your triangle. Now you might have to use SOHCAHTOA. So keep that in mind. So think about your triangle that you have drawn. I'll just redraw it up here. So we have this is 8, this is 22.5. Let me put that in red here, 22.5 degrees. And we want to find this side down here. Well, think about SOHCAHTOA. This is opposite. The x is opposite of our angle. And the 8 is adjacent. So opposite and adjacent, part of TOA. So we're going to do tangent 22.5 equals x over 8. You're going to multiply both sides by 8. And then you're going to type that in your calculator. And when you type that in, I think you get x equals 3.31. So what you now know is this little spot is oops. Let me get rid of that there quick. Sorry. This little spot is 3.31. But to get the whole base, you're going to have to double that. So it'll be 6.62 all the way across there. So the base of our triangle is 3.31 times 2, or in other words, 6.62. Step 4. Now we find the height of the triangle. Holy buckets, this is good news, people. We already know the height of our triangle. It is the 8. So 8 is our height of our triangle. We don't have to do any work for that. It's already given to us. Step number 5. Now you find the area of your triangle, which remember, it's base times height divided by 2. Well, the base was 6.62. The height is 8. And then multiply those together, divide by 2. When I do that, I get 26.52. Our last step, step number 6, is now we know how big each triangle is, 26.52. Now we have to multiply by the number of triangles or the number of sides. In this case, it's an octagon, so we'll multiply by 8. And I wind up with 212.16. Again, if you end up with 211 or 213, it's just because of where you rounded. Don't worry about it. On the quiz, you'll just pick the choice that's closest to 212.16. Okay, last one. Number 6, find the area of this regular pentagon below. We're going to go through the 6 steps. Step number 1 is you find the central angle. So you're going to take 360, divide by the number of sides. It's a pentagon, so there's 5 sides. 360 divided by 5 is 72. We just found this angle right here. Step number 2 is you are going to take that angle, that central angle, and cut it in half. Why do we cut it in half? We cut it in half so that we end up with a right triangle. So 36, I believe, is that number. So this angle right in here is 36, and over here is also 36. It's kind of hard to read that. Okay, next, step number 3 is we have to find the base of our triangle. Now we're likely going to have to do SOHCAHTOA. So the base is the whole distance from A to B, but I would start by just finding half of it using SOHCAHTOA. So let me redraw just that part of the triangle. This is 9, this is 36, this is the side we want. So figure out what you have. The X is opposite. The 9 is the hypotenuse. Think about SOHCAHTOA and choose the one with the O and the H. You should choose so. So you're going to do sine of 36 equals, it has to be opposite over hypotenuse, so X over 9. Multiply by 9 on both sides. And then type in your calculator, 9 sine 36. If you did it correctly, you should get 5.29. Now remember, that's only halfway across. The 5.29 is just this little part right here. So you have to double that to get your base. So the base of the triangle is 5.29 times 2, which is 10.58. So 10.58 is the whole way across down there. All right, step number 4. Step number 4 is you have to find the height of your triangle. Well, we have not been given the height. So like, let's call this y over here. Now we have to find y. What I would do is I would use the 9 and I would use the y. So you're going to use adjacent and hypotenuse. So you're going to use cosine. Cosine of 36 equals adjacent over hypotenuse. So y over 9. Multiply by 9 on each side. And then type in your calculator 9 cosine 36. Remember, your calculator has to be in degrees. So if you're getting really crazy answers, try checking the mode on your calculator and changing it to degrees. Okay, when I did this, I got 7.3. So y was 7.3. That's also the height of your triangle. So we have the base of our triangle. We have the height of our triangle. So step number 5 is you're going to find the area of your triangle. Wait a second. Sorry. The area of your triangle, which is going to be base times height divided by 2. So we're going to take base, which is 10.58, times height, which is 7.3, and divide by 2. And we'll type all that in, and we get the area of our triangle is 38.62 centimeters squared. Now, how many triangles will it take to fill up a pentagon? Well, step number 6, I'm just going to put it off to the side up here. You take your 38.62 and you multiply by 5 because a pentagon has 5 sides. And it comes out to be approximately 193.09 centimeters squared. Phew, show those to your parents. They'll be amazed at all the work you have to do just for one problem. I know how much you love homework, so your next job is to do the 11.3 homework. If you get stuck, look back at your notes, look back at the 6 steps, and you can always message me also. Good luck. Have a good day.